Good afternoon, everybody, and welcome to iTnews' first Academy webinar. We're trying to take the concept of the webinar to a new level, obviously adding video, but also some deep dives into the new features of the software products in the enterprise space. And today, I'm very grateful to have Jeff Alexander, who's a technical evangelist for Windows infrastructure, who's with us to talk about the latest features in HyperV, which of course is bundled into Windows Server 2012. Jeff, thanks for coming in.
Thanks, Brett.
Obviously, the Windows Server platform is a pretty broad beast. There is a lot of features in it, and being that we're live and we only have 1 hour to do this, I've asked you today to just focus on the latest virtualization features.
Yep.
If possible, could you perhaps start out by giving us a little bit of an insight into, I guess, top level, what Microsoft was trying to achieve with Windows Server 2012 and how the virtualization features play into that?
Yeah, sure. I mean, today we've got an agenda here that your readers want to know about. So we're going to be covering important business workloads that scale and performance improvements.
Mm-hmm.
We're going to be covering increases in flexibility, virtual machine mobility, continuous services, all that stuff that your users want to look at. But when we look at Windows Server 2012, the main focus that we had with Windows Server 2012 is really about cloud optimizing your IT. And you're probably wondering, what the heck does that mean, right? I mean, cloud optimizing your IT is really these 4 pillars that you see on slide right now is about taking virtualization to the next level. And that's actually about taking virtualization to scale all workloads that you want to actually run. Scale and secure those workloads, do it in a cost-effective way. Our goal with cloud optimizing is being able, you as a customer or your customers to be able to actually build private clouds, secure their workloads in a hosting partner and also in the public cloud. So the operating system that we use on Windows Azure is Windows Server 2012. Okay, so there's a couple of other areas here that are on here around the power of many servers, the simplicity of one. But this is, today we're really going to be focusing on Server 2012 and particularly the virtualization piece.
Okay.
All right, so when we look at that, there's a whole bunch in there, and you and I have talked about just how much is actually in Windows Server 2012, and this slide that we've got up here now is talking about just the facts about what's in this big release of Server 2012. It's a major release from 2008 R2, and we're going to be covering scale, performance, virtual machine mobility, continuous services, and we're going to talk about each of those, and we're even going to get a chance to show some of this stuff as well.
Great.
And then we're going to be talking about isolation and multi-tenancy. In the limited time that we have, we can only talk about those certain things. So those are the things we're going to dive down into today.
Great. Well, let's dive into the first of them. I understand scale and performance was the first thing I wanted to talk about. The difference between 2008 and 2012 in terms of sizing, I guess.
Okay. So when we look at scale and performance, it's you probably have a lot of customers that want to run in a virtualization environment. And we're looking at running your most demanding application workloads. This is anything that you want to run. SQL Server, Exchange, SharePoint, all those different workloads can now be run in a virtualized environment. So when we talk about scale and performance, some of the changes that we made is bigger, faster virtual machines. And I'll talk about in an upcoming slide about just some of the scale that we're actually talking about and also show that as well. And then, looking at hardware offloading, being able to take some of the workload away from the CPU that's in the HyperV host and offload that to hardware. Okay. Things like network cards and storage and all this kind of stuff can be offloaded so that they can take the brunt of some of the workload performance that needs to be done for that particular workload. And if you look at some of the scale, and other applications themselves will now take advantage of some of the new hardware technologies that are coming in servers these days, particularly around non-uniform memory architecture. This is all about scale and performance, being able to take us to that next level, because when we start to build private cloud, we need to be able to scale to these workloads. And have a look, we've got an eye chart here for your readers. Okay. It's always good to have an eye chart when we're doing this. So if you look at this, these are some of the raw numbers that we looked at for Server 2012 when we looked at this. And during the development of Server 2012, we even increased these numbers from the release candidate to when we went to release to manufacturing.
Okay.
So if you look at some of these numbers, and I'll call out a couple of these, your readers can read the screen, but some of these numbers, if you look at the sizes of virtual machines, we have a 16 times improvement compared to Server 2008 R2 in regards to the number of processors and the amount of memory we can assign to a virtual machine. So these are some huge numbers that we actually have, and we'll talk about clustering later on, but we'll talk about the fact that we can now have 64 nodes within a cluster compared to 16 before, and we can have 4,000. Actually, that slide is incorrect. It's 8,000 VMs per cluster.
Okay, it's been updated since.
Yeah, that was a change that we actually made from the release candidate to the release of Windows Server 2012. So there's a massive scale that we have to be able to run users' most demanding workloads.
Well, I'm itching to get into our first demo. I believe we can show some of that scale in practice.
We can indeed. So we'll switch over and we'll show and have a look at a demo. So I have a demo here that we can actually look at. So let's just switch over to that and have a look at this demo. Okay. So as we saw in the slides, Windows Server 2012 scales up to very large workloads. And what we have here is a virtual machine that is an example of what this actually looks like. And as you can see from what we've got running here is Task Manager. Task Manager is showing us the number of virtual processors that are assigned to this virtual machine. And as we click in and zoom in a bit further, you'll notice that this virtual processor has 64 virtual processors attached to it. That is something we couldn't do in prior versions of Windows Server. Now we have that ability in HyperV on Server 2012. The other thing that we've added is very large memory support, and now we can go up to very large memory support here. You can see a virtual machine with 1 terabyte of virtual machine assigned to that virtual machine. And the last piece is the ability to have very large virtual hard drives, which is the hard drives that support the virtual machine, up to 64 terabytes. And so if you look at this here, and this properties of this virtual hard drive, this virtual hard drive is 64 terabytes in size, which is absolutely massive for enterprise workloads.
Jeff, as I understood it previously, the maximum size of a virtual machine was something like 2 terabytes, I believe. What was the breakthrough that enabled us to get to this kind of scale?
Well, we got to this scale with a new format in Server 2012 called the VHD-X format, which is a new virtual machine format that was completely rewritten from the ground up to allow us to address the limitations that we had in the VHD format. And this new format allows us to get to much, much larger size virtual machines. So this allows customers to scale up to their huge workloads now.
Great. Okay, great. Well, thank you for that, Jeff. I guess
pretty cool, huh?
Yeah, very good. Well, the next thing I want to look at is virtual machine mobility. I know it's something that I certainly focused on when I looked through the key features. Based on the feedback from our readers, that's something they've been demanding from Windows.
Yeah, well, we'll have a look at that. In the area of virtual machine mobility, there was a number of focus areas that we had with Server 2012. And really what this is about is we want to be able to manage our virtual machines independent of the underlying infrastructure that we have. You know, if you look at the virtual machine format, the VHD format is actually an industry standard term for how we actually look at virtual machines. So we need to be able to actually handle the needs that customers actually have on demand, you know, moving workloads around, all that kind of stuff. So there's 4 areas that we actually focused on in this particular piece. First of all, live migration. Now we've been doing live migration since Windows Server 2008 R2. So we've been able to do live migrations within a cluster, which is the primary way that we actually do live migrations. A couple of things that we changed with Server 2012 is multiple simultaneous live migrations with Server 2012. So that means we can do as much as the hardware can handle. Okay? So we can do live migration within a cluster, and now we can do live migration outside of a cluster by being able to do live migration of the storage, doing shared nothing live migration, and also doing what we call live migration to a disaster recovery site through HyperV Replica, which we'll actually cover in a minute. So there's a whole bunch of things that we've done around this to help this. And if you want to dive down, we'll dive down into a little bit about what this looks like so the readers can actually see what it looks like on screen.
Okay, what's the first of them you'll go into?
So the first one is really looking at migrating our virtual machines without downtime. And the first piece is really to be able to do this from a file share. Okay, so traditionally in virtualization environments, the way that we actually stored virtual machines was on local disk. you know, local attached storage or in a cluster or in a, you know, in a SAN or something like that, which your readers would probably be very familiar with. What we can do now with Hyper-V in Server 2012 is store those virtual machines on a highly available SMB file share. So that means that we can move that virtual machine up to a file share that's highly available, maybe even clustered, and then we can move we can live migrate that virtual machine, and all we're moving is the identification of that virtual machine and where it's currently sitting, and the storage handle.
Oh, so the pointer, so to speak.
The pointer to that virtual machine.
Okay.
So that means that the live migration is a lot faster. And of course, with any live migration means that there's no interruption to the service for the application, or no interruption to what the user is actually using at the time. So the user is completely unaware of what's actually going on in the background. This is really to help the administrator. So I just want to set this up for you so you can actually see what it looks like. And so on the slide, what you're seeing is we have a file share, which is where we're storing our virtual machines down the bottom of the screen, and we're going to move our workload across to the other node. And essentially what we have to actually do is we have to set up a connection between that Hyper-V host and the Hyper-V host we want to move to, and that's done through an IP connection. Okay, so we set up a connection to that machine, and we're going to go and make a second, an exact copy of that virtual machine on the other node in that particular target host. So what we do first of all is we move the configuration data, and this is that pointer you were talking about a few minutes ago. So we move the memory content, the configuration data, all gets moved over to the other node, and we have no interruption to the service while that's actually going on. Okay. So the memory pages then get transferred across, and you know, when users are using machine, what are they actually doing? They're writing things to that virtual machine. So these are called memory pages. And so by moving those memory pages across, we then have to keep track of any memory pages that are actually changing.
That are changing in real time.
Yeah, in real time. So we have to make sure that before we actually move the storage handle across to the other node or the other target host, is we have to make sure that they match.
Okay. Okay,
so when we keep going on this particular slide and we build that out, what you're actually going to see here is that we're going to modify, those modified pages get transferred. We make sure that they match up, and once they actually match up, then we go ahead and we move the storage handle across to the other node.
So there's a lot of preparation, I guess, a lot of traffic, just preparing for that moment when you make sure that you're completely up to date, and then you move the storage handle.
Correct. You move that stuff across, the storage handle is moved, and then the administrator can go and make any changes or any maintenance that they need to do to that other source host that they had. All right, and then we have the next one that I talked about, which is the shared nothing. This is probably one of the most exciting features on Server 2012, is this notion of what we call being able to actually move a workload with nothing more than a network cable.
Okay.
Okay, picture that. So we're outside of a cluster. All we need is a network cable to be able to actually move that. And it works the same way as we did with our highly available SMB file share, in the sense that we do reads and writes of that source VHD. We're going to make a complete copy of that virtual machine over on the other destination host. We're going to copy the configuration data, the memory contents, and we're going to keep track of all that memory on that original host to make sure that we're not going to lose anything on that. And so what you're seeing in the diagram is it's kind of like following the orange ball in this diagram. It's always good to have animations on your slides. And what we're doing here is we're just making a copy, we're keeping track of the data that's going on. Reads and writes are happening during that live migration, and you'll see that that dot moves back and forth, and this is actually going down through the storage stack. Okay, so instead of going over the IP over the network, this is going over the storage stack. And so disk contents are copied to the new destination VHD that we've created on the host, the destination host. And then that's moved over, and then we synchronize any disk writes. And they're mirrored for any outstanding changes that were made and replicated. Okay, so those are moved across, and then once we have that all in synchronization, the live migration is actually completed.
You know, it actually probably looks more complicated than it needs to on the animations. As much as I love them, could you show us it on the server?
Absolutely, we can show you this. So let's move over and we'll have a look at what a demo looks like of shared nothing live migration. Okay, so as we saw in the slides before, we had the ability to get much more virtual machine mobility with Server 2012 and allowing us to move our workloads. And in this demo, I'm going to show you how we can actually move virtual machines around with nothing more than a network cable. Okay, so it allows us to move that virtual machine with nothing more than a network cable. Previously in Server 2008 R2, we had to have our virtual machines as part of a cluster and in shared storage. With Server 2012, we have this notion of what we call a shared nothing migration, which means we can move virtual machines around between different hosts that might not be part of a cluster. So let's have a look and see how this actually works. So I'm going to go up and open my HyperV Manager, which is where I manage all of the movements of my virtual machines. So here you can see I've got a workload, Server 3, running on HyperV host 1. And I'm going to move that virtual machine over to another machine that's not part of a cluster. And it's a fairly straightforward process for us to go and do that. Simply have to go and select the machine, go to the Action menu, and choose Move. And this brings us into a wizard. That is a fairly straightforward click next and follow the bouncing ball, and you're able to actually move your machine around. And in case of, you might have an administrator that needs to do a patch on this virtual machine. Okay, so we can patch this host and then move the virtual machine over to another host. So let's go ahead and go through this process. Now we have a couple of options here. We have the ability to move the virtual machine, which is moving the storage to another computer running Hyper-V. Or we can move the storage, which we'll talk about in an upcoming slide. We'll go through a little bit about what we do around moving storage. And we'll just click Next. And now what we need to do here is, you notice I'm going to be choosing the host that I want to move this to. And this host is just another host that I have connected to this first host via a network cable. And I'm going to move that across to that particular machine. And you can notice that I get three options here. I can move the virtual machine's data to a single location. I can move its data by selecting which items I want to actually move, or I can actually just move only the virtual machine, which is a reference pointer to the machine in Hyper-V. I'm going to choose to move the virtual machine's data, and I'm going to choose a location. And you notice that this is a difference than what we had prior to Server 2012, in the sense that we can choose local storage here and move this virtual machine to local storage, which makes it a lot more mobile for us to move our workloads around. And it's a simple case of hitting finish. And then here's what's happening is we're performing the move.
And while that's happening, what's happening from a user perspective if you're working on an application that relied on that virtual machine?
Yeah, no, that's a really good question. Now, we showed you a couple of slides before where we were actually bouncing around, little data was actually moving around. And what we're actually doing is we're taking a copy of this virtual machine and duplicating it on the other host. And the user at the other end is absolutely none the wiser of the workload. There's no interruption to the workload that they're actually running. They have no downtime whatsoever. They don't even aware that their workload is being migrated to another host. They don't even care. So what will happen during this move is that we'll make a complete copy, and then right at the last second, we'll move all the contents over to the other host, and the user won't know anything different whatsoever.
Great, okay.
And we'll just click Finish on that, and then our workload is now moved over to the other node in the cluster, and we're all good to go.
Okay, great. Thanks, Jeff. Now, as it happens, just a couple of days ago now, over at TechEd, there's been some announcements around the new R2, Windows Server 2012 R2, and I understand that there's been some changes made around live migration, particularly the speed at which you can...
Yeah, there has. Earlier this week at TechEd North America, we made some announcements of Windows Server 2012 R2, which will come out later this year. And one of the areas that we improved is live migration, which you just saw in the demo. We've increased the speed of live migrations through compression. Okay, so what that means is that we compress the data as it's actually being migrated, and this gives us a 2 times improvement right now to be able to migrate those workloads.
2 times faster.
2 times faster than it was on Server 2012 with Server 2012 R2. So it's about making sure that administrators can get their work done and be able to actually move this stuff around in a much more easier fashion.
Great. Well, that's the first part of migration of VMs, but what about when there's storage tied to it? Can we move on to moving virtual machine storage with that?
Yeah, so the last piece around virtual machine mobility is really around live migration of storage. That was something that we added in Server 2012 to be able to move storage. So in this diagram, it's a similar diagram to what we actually saw before, but what we're looking at here is not a target server, but we're looking at a source storage device and a target storage device. And essentially what we mean is that we can manage our storage in a cloud environment. So a lot of times what hosting providers give you is flexibility in the way that storage is actually handled, in the way that it's moved around. So we've taken a lot of what we've learned in running big data centers on Windows Azure and being able to actually bring this into the operating system. So this is about moving virtual hard disks that are attached to a running virtual machine with no downtime. Okay, so essentially what we're going to do here is the same thing. Disk contents get copied to the new VHD or VHDX file. And so what we'll do is you'll see that disk writes are then mirrored just like they were before, and they're replicated over to the new VHD. And then what we actually do at that point is read and writes start to go to the new VHD, and we compare those reads and writes with on the destination VHD with the source, and we keep track of those pages just like we did before. So what that allows us to then do is to then move that machine right over to that particular machine. And allow us to move the storage.
Okay, well, one further part of the virtualization feature specifically is around business continuity.
Yes.
When we had a recent data center conference for iTnews, I asked all of the attendees at the conference what their highest spending priority was for the coming 12 to 18 months, and wouldn't you know it, business continuity came up, which surprised me actually. But I guess there's changes in the works from the very expensive solutions they might have had in the past that were only available to top enterprise seem to be filtering down, and I believe Windows Server has some examples of that.
Yeah, well, this is all about making sure, you know, as we look at virtualization, we believe that virtualization should be core to the platform. So the virtualization itself should be a core feature of the platform, and we also believe that business continuity should have that capability as well. So in Server 2012, we've introduced a new feature called HyperV Replica. Okay. And HyperV Replica is an in-box business continuity solution to allow businesses to quickly recover. Now, you know that we've heard a lot in the news about disasters that have happened around the world. Hurricane Sandy in New Jersey in America, the floods in Queensland. I've talked to a lot of customers up in Queensland, and a feature like HyperV Replica is something that they're very interested in. Because what it allows them to do is, through a few clicks in the HyperV console, is to replicate their workloads from a primary site to a disaster recovery site and do it over the network. Okay. And essentially what it means is that we do this asynchronously, and we do it over HTTP and or HTTPS. So it's inbox. It is very, very simple to set up, and it allows us to take those workloads, move them over and replicate them, and then when a disaster strikes, we can fail over to those exact same workloads. And we had this situation happen at TechEd last year, and the time that we were actually down was basically the time it took the administrator to walk from one end of the convention center to the other, which was 4 minutes. So we were able to recover all of our services just like that due to a hardware failure.
If only iTnews had this kind of technology.
Yeah, no, that's fantastic. And there's no need for storage, there's no need for any other software replication technologies. It's just something that you turn on in HyperV.
Great. Well, before I bag out my publication's ability to keep its website up any further, let's move on to a demo.
Yeah, let's have a look at it, because it's pretty cool when you actually see it in action. Okay, so you know, we all are aware that there are natural disasters. I wanted to now show you, now that we've had a bit of a look at moving storage around, and I want to show you now a new technology in Server 2012 called HyperV Replica. And HyperV Replica is our in-box disaster recovery solution. Okay, so it's part of Server 2012, it's part of the HyperV role. Allows you to basically take a running virtual machine and replicate that to a disaster recovery site. So that, you know, in the case of you know, a whole site going down or something happening, we can keep our business running and have that you know, continuity of services, I guess you could say.
Okay.
So what we're going to do is we're going to go and run HyperV Manager. So first of all, what we need to do is we need to find out the IP address of the server that we actually want to replicate. So the first thing I'm going to do is I'm going to go and resolve the DNS name of that particular server. So you notice that that server, all we've done is just do a query on that particular server to see what the IP address is. And you notice that that IP address is the last two digits are 32. Okay. .32. So keep an eye on that, because I'm going to come back to that in a second so you can see what that's like. All right, so we're going to go and run Server Manager, and we're going to open up HyperV Manager, and we're going to enable replication on on our workloads and move it over to the other site. Now you notice here that we've got two hosts. We've got host 1, which is in our primary site, and we've got host 2, which is in our disaster recovery site. And what we're going to do is we're going to enable replication for that particular virtual machine to replicate over to host 2. And it's simply a case of selecting the server and then going down to the bottom of the HyperV console and enabling replication. Okay, so all we need to do is go and run through a wizard. And the first step of that, of course, is to specify the server that we want to replicate this to. So I'm going to specify host 2. And of course, there's some stuff we need to do on host 2 before we actually do that replication.
What would we need to do to make sure that it came across?
Well, first of all, what we need to do is we need to go and enable replication on host 2 so that that host can actually receive replications from other hosts.
Okay.
And we do this over either HTTP or HTTPS. So standard protocols that people would be familiar with.
But in any case, it's just another GUI that's very similar to this.
Correct, yeah. You go into the HyperV Manager and you go into the settings of that HyperV host and you just enable replication from there. You can even specify which servers you want to actually receive replications from.
Okay.
Okay, so you can get very specific about which servers are allowed to actually replicate to that box. So we're going to go and choose host 2. And we have a couple of options in the way we're going to do this. As I said, we can use HTTP, which is our Kerberos authentication, or we can use certificates with HTTPS. And you'll notice down the bottom of the screen that we compress the data that goes over the network. That makes it much more efficient over the wire, right? So we'll hit next there, and it's going to ask me, which VHD file do you want to actually replicate over to this host? And we're going to hit next there. And then we have the option to set recovery points, and we're going to come to recovery points in a second when we do a couple of things later on. But we have the option of using only the last recovery point, or we can go and specify additional recovery points. If we feel that we're in a risk of having more natural disasters or something like that, we can set a few more recovery points if we want to. And this is a great thing as well, is that you notice the size of that copy is an 8 gig file.
Okay.
Right? That's a lot to be copied over the network, right?
Absolutely.
So we can either send that initial copy over the network, or we can get the intern to sneakernet it over to the other site, right? So they could copy this onto an external media, bring it over to the site, and then do that initial replication with that physical media at the site. So that makes it better for customers not having to move so much data in their first initial copy. And then down the bottom, you'll notice we'll have a replication schedule. We can choose the time of day that we want to replicate, so we can do this out of hours if necessary.
Great.
So we'll hit next on that, and then we're going to hit finish, and then that's going to start to replicate this. And then what we're going to do at this point is we're going to go and simulate a couple of scenarios. All right. So you'll notice that over on host 2, that server is there, but it's off.
Okay.
Okay. We don't want to bring that server up and have it be on, because then we could have conflicts going on with the same server being on. So we have that server in an off state, and then what I'm going to do now is I'm going to go down into the settings, and I'm going to go down into the network adapter, and we have these. Once we enabled replication, you'll notice that we have an option for failover IP address settings. Okay, because whenever we do a failure, we don't want to bring that server up with the same IP address.
Of course,
because we could run into some conflicts. So we're going to go and specify another IP address that we want to use instead of that one.
So 3.1 instead of 3.2.
Instead of 3.2, yes. And we're going to use the same subnet mask and the same gateway, and all that kind of jazz is going to be the same. So we'll put that information in. We're going to apply that. Go OK. And then at this point, we can go and test a few things.
Okay. Can we test, for example, that killing it? Could we practice a failover? So
yeah. I mean, we could go and simulate a planned failover, or we could simulate a disaster where a server was turned off by mistake. That never happens in the enterprise, I guess. So let's go and we'll do the first one. We'll do a simulated failover. So we're going to go back over to our host 1, and we're going to scroll down and do our failover on this particular virtual machine. Let's see if I can get this thing to scroll down for me. So select that one. and we're just going to shut it down. All right, so that's a simulated failure. Okay, so that's we're going to go and shut that down, and we're going to turn that virtual machine off, and we're going to go over down here to our replication, and you notice we have a couple of different options here. We have planned failover, we have pause replication. Okay, so we could pause the replication if we didn't want to do any replication. We can view the replication health, and that's important to be able to understand how is our replication actually going. Are we replicating okay, or that kind of stuff? And we can completely remove replication if we wanted to. If there's no need for us to replicate to that site anymore, we could do that. But we're going to go and do that first one that you mentioned. You asked about whether can we do a planned failover. Okay, so what we're going to do here is we're going to start a replication here, and we're going to fail over to the other node. And what you see is we get a successful message here to say that we were able to fail over that node fail it over to the other host. And
because we'd set up both already.
Yeah, we set it up already, and you notice now that server is actually running now on the other host.
Got you.
And our services are continuing, so it allows us to get that high availability. And let's go back down over to, we'll do another scenario. So we'll go and select this box, and we're going to do what we call this is not a planned failover.
This is not a nice failover.
Yeah, so maybe an administrator is disgruntled and he leaves the office and he decides, I'm just going to go and turn off the main application that's running. I'm turning that off, and that is not expected for us. So what we're going to do now is we're going to go and do a failover to the other host, and what you're going to see now is we're going to go back from, now that we've had a complete disaster in our site, HyperV Replica has picked this up, and if we go back to our host here, you can see we have the option to do failover, and that allows us to failover from a recovery point. And this is very similar to like what we see in file history today, where a user can go back to files that they might have had a couple weeks ago. What we can do is we can set recovery points here for our servers to go back in time. Okay. So that server can actually be failed over and run at that.
And all that can be scheduled. You can have a point in time according to how you set up the server.
Correct, yes. So we're failing that over now. We're running through the process, and we're failing that particular machine over. And I'm going to go and start PowerShell, and I want you to notice as we resolve the DNS name of that box. Remember, we had it 32 before, and we went and actually set our IP address to have the last 2 digits to be 31 so that we don't have any conflicts. So what this means is that we've been able to actually specify the IP address, and we've been able to avoid a disaster in both a planned and a unplanned failover scenario.
Do you have any examples of the latter that you've been involved with where you've seen this software at work?
I've heard it happen in some of the disasters that happened recently in the United States and also here in Australia. I was up in Brisbane recently, and a lot of the folks up there with the floods that happened recently are very interested in this feature because it means that they can take their existing services and they can replicate it somewhere else.
Yeah. And
if something happens, then they can get that back. And it's a powerful thing to have built into the operating system now.
Absolutely. Built in is I guess, the key, because asynchronous replication is a feature that I would usually have expected in the past in the array, perhaps, and certainly at a standalone product at a high price point. But,
yeah, absolutely. It would have been something that you would have had to go and spend a lot of dollars, I guess, to get this kind of functionality, and now we just have it built into the operating system.
Very strange to see it in a GUI in the industry standard.
Yeah, absolutely.
Operating system.
No, it's awesome. It's and we're starting to see a lot of customers use it now because they see it as just a set and forget kind of scenario that they can. It's kind of like having insurance in a GUI.
That was great. Just to clarify though, you mentioned that you need to set up the target secondary site to some degree to mirror the primary. So what are the things you've got to consider?
Well, it's very simple. Basically what you do is you go over to your secondary site and you enable HyperV Replica for the HyperV host server. And there's a couple of things you can do there. You can allow replications to come from any host. Okay, so you can go into the console and say, allow replications to come to this HyperV host from any server, or you can specify specific servers that you actually want to do replication from. You can also specify which port you want to actually go over, because I guess you get a lot of customers asking, do I need to do anything on my firewall? Do I need to do anything? All you have to worry about is port 80 for HTTP or port 443. Okay, so essentially what that means is that you can either do HTTPS replication or HTTP replication over port 80. One is more secure than the other. So that's all we require. And then what you do on the primary site is you enable replication on an individual virtual machine basis. So you just basically go right-click on the virtual machine, enable replication, 4 more clicks, you're replicating that guy over to the secondary site. That easy to do.
Great, okay, and HyperV Replica, as far as I'm aware, is not the only feature of Windows Server 2012 that's aimed squarely at business continuity. Have you got some others that you can share with us?
Absolutely, yes. So if we move on into continuous services, there's a number of things that we're trying to focus on here, and really what we're trying to do is make sure that as we move towards virtualized world and private cloud, is we have to maintain continuity and keep those virtual machines up and running. So there's a couple of things that we have to be able to do, because we know that there's going to be infrastructure changes within the environment. So we have to make sure that when infrastructure changes do occur, we have to maintain those availabilities. And a lot of the clustering capabilities and live migration does that. But we've made some enhancements to clustering itself. One of the key things we've actually done is a technology called cluster-aware updating. And your readers would be very interested in cluster-aware updating from a maintenance point of view, is that if you have a 2, 3, 4 node cluster, you've got a lot of hyper hosts that you actually have to keep patched. And as we all know, Patch Tuesday comes out, or Patch Wednesday as we call it here in Australia, comes out every month, and you got to patch these things. Cluster-aware updating allows you to basically set up your patching for those servers once, and then it will take care of all your updates and move the workloads across back and over to the other nodes in the cluster while it's updating one node at a time. Okay. And the administrator doesn't have to do anything about that. You can print reports and find out how the updates actually went. It's fantastic. And the other thing is around quality of service. I'm sure your readers have heard about quality of service. I think we've been talking about this for a number of years.
Yeah, the impact of virtualization sometimes on network can be quite extreme. Yeah.
So we have the ability to implement quality of service, and we'll talk about that in a few minutes. And then we've added another thing in the operating system called NIC teaming. Previously to Windows Server 2012, this was a technology you had to purchase from a hardware vendor. Okay, so if you used a particular hardware vendor, you had to do NIC teaming as a third-party solution. Now it's inbuilt in the box, and what it means is that you can team up to 32 network cards together, so that if one network card dies, or the case of the intern IT administrator comes by and kicks the cable out of the wall or something, and you're not going to bring down your services. Okay, so we can set them up in a team so that we have some reliability at the network layer. So it's fantastic. So we can have a look at a little bit more detail about some of the clustering enhancements, and then we'll move on into some other areas. But when you look at the clustering enhancements, the whole here is to make sure that our applications are available all the time. So we've added some more applications that are cluster aware. So we have the ability to set up highly available scale-out file servers for Hyper-V and for SQL workloads. One of the things that you may not know about is that SQL Server, you can now run your databases and your log files on a shared file share now. So that what you can do is that you can protect against the application, particularly around SQL Server, failing and falling over. So some of those cluster-aware enhancements, having a scale-out file server, and it's really giving you a high availability for the key workloads like SQL Server and Exchange and stuff like that. So having that high availability is something that you really want to have. So it's about increasing the availabilities and enabling access to those server-based applications through that. And if we look at some of the the nitty-gritty detail, we now have the ability to do guest clustering directly to the fiber channel. What does this actually mean? It means that we can those workloads that require fast access to the SCSI port of the fiber channel can now get access that directly.
No switch in the middle.
No switch in the middle. They can basically connect to the fiber channel directly from within the virtual machine. And we've seen that SQL workloads sometimes need this capability, so they can get direct access to that. We can BitLock or encrypt cluster volumes now, so better enhancing security. And live migration enhancements, we can now take advantage of multiple simultaneous live migrations, and we can do live migration over 10 gig E networks. Now we've heard a lot of customers that are actually moving towards 10 gig E, which allows them to get faster migrations. And then CSV, which is the underlying infrastructure that we have for cluster shared volumes, is much more simplified. for virtual machines. You store your virtual machines in a CSV. It means that enables you to have much more integrated and highly available live migrations.
Okay.
Okay.
Before we move on, I heard again some talk of R2 having another extra for continuity purposes. Something about the resizing of VMs on the fly.
Yeah, I mean, obviously a lot of customers want to keep their workloads up and they don't ever want to actually turn them off. So to allow us to do that, we've allow you to actually resize VHDX files on the fly while the machine is actually running. And where we actually see a lot of customers doing this is, for example, they need to add more storage to a running VM.
Okay.
So what we can do is we can dynamically resize that VHDX when it's attached to the SCSI port. So that gives us real flexibility and continuity of services because we no longer have to.
What would we have done before? What would have been?
We'd have to shut the machine down, change the size, extend the size of the VHD, then go into the VHD and extend the volume, do all that kind of stuff. We can do this live now with R2. So that's a fantastic new thing coming later this year.
Excellent.
All right. Moving on to the next area.
Okay, quality of service, I believe we're going to talk about as part of the picture around virtualization, particularly multi-tenancy, I guess. How do you guarantee the performance of an application or for a set of users?
Well, there's a couple of things in the area of continuous services. We've added this new thing called QoS in HyperV, which really allows us to establish what we call a relative bandwidth floor. So the bandwidth floor means that we're going to guarantee a certain amount of bandwidth for how much storage we're using, how much network bandwidth we're actually going to be using, how much CPU, all that kind of stuff can be measured. So it allows us to get a relative minimum bandwidth or a strict minimum bandwidth that we can actually set. We can also set a bandwidth maximum. Now a bandwidth minimum and a maximum are different in the sense that some applications will actually require a specific amount of bandwidth to run correctly, and you've seen this with distributed applications in branch sites and stuff like that might need a specific amount of latency or quality of service. So we can set a bandwidth minimum that can be then incorporated into your SLA, which means that you can measure what's actually being used. The other thing we can do is we can assign specific bandwidth for each type of traffic, whether it's storage, whether it's networking, whether it's CPU, all that kind of stuff. And we can also ensure fair share around congestion. So we don't want a particular workload to take up too much bandwidth and affect other workloads that are running on the same Hyper-V host. So we have this notion of what we call fair share. So we do this through the package scheduler, which is in software that we actually do this, and through the network adapter that supports DCB, which is an offloading technology that allows us to offload some of that processing to the adapter itself. If we look at this in a little bit more detail, if you look at this in the slide, is that you see here on this slide we have some additional workloads. We have the service that we're actually trying to implement QoS on. It could be on the virtual machine. It could be on the storage that's supporting the underlying virtual machine. It could be during a live migration, because oftentimes the customers will specify a specific network for live migration, so we can actually change that. And you can see here that we have a reservation that we can do for quality of service. We can say how much do we want to reserve for this particular service. And then we can set certain levels on the different types of connections that we actually have. So we can get very, very granular, and then we can measure what is the bandwidth that each one of these is actually using.
Okay. Well, can we dive onto the surface and connect up? And
we can dive onto the service and have a look at this. And so let's have a look at a quality of service demo. Okay, so now what we're going to actually show is quality of service. We've been talking a bit in this section about continuity of services and being able to actually guarantee continuity of these services. So what I'm going to be showing in this demo is how we can actually guarantee certain quality of services, things like minimum bandwidth, maximum bandwidth, so that we can actually start to deliver IT as a service and be able to actually deliver the SLAs that we want. So let's have a look at that. The first thing to do, obviously, is to go up and open our good friend HyperV Manager, which we've been showing you a lot today, which is good. And you can see here on the screen that we've got a host running a number of different virtual machines. And we want to enable quality of service on our domain controller because that's our primary workload where we're providing services to the business. So we're going to go over to our domain controller and we're going to go to settings on that domain controller. And we're going to go down to our network adapter. And you notice that right out of the GUI, out of the graphical user interface, we have the ability to enable bandwidth management right there on that virtual machine. Mm-hmm. So this is fantastic, being able to say, okay, you, Mr. Customer, or the application that you're going to be using, how much bandwidth does that application actually require under normal circumstances? And we can set a minimum bandwidth, plus we also don't want that application to run away and steal bandwidth from other applications, so we can set a maximum on that as well. Now, Of course, quality of service is not on by default, so we will need to go in and enable that. So we'll just cancel out of this box, and then we're going to minimize Hyper-V. And a lot of this stuff we're actually going to be doing from our administrative climate, and I'm going to go and simulate quality of service in this particular scenario. What I'm going to do is I'm going to copy a very large file to my domain controller so that we can show quality of service in action. So the first thing I'm going to need to do is I'm going to need to run and find the file that I want to copy. Okay, so I have a local file on my sources directory, and this is essentially a 3 gigabyte file that's part of the Windows 8 or Windows Server 2012 installation DVD.
Big enough to make an impact, I guess.
Big enough to make an impact. You know, you've ever had people start copying stuff on the network and everybody's running around going, what's going on? Why is the network slow? Well, here we can actually show quality of service in action. So the next thing I need to do, obviously, is put in a location of where I want to copy that to. And so I've got my source and my location. I'm going to find my install.wim file, which is my fairly large file that I'm going to copy, and I'm going to go and copy this over to my domain controller, and I'm going to paste that in, and it's going to do a standard copy, and that's going to copy that out, and it's going to take all the bandwidth that we actually have on the network to be able to do its copy. But we want to go in and actually limit that, so we're going to do that at the host level. So we're going to go and run and you'll notice it continues to copy and everything seems to go. And we're going to go and minimize the copy that it's going to have here. And it's simply a case of us going and setting this. I'm doing this at PowerShell, but I could have done that in the GUI before. Remember, we were in the GUI before and it showed you the minimum and maximum. Here that's the PowerShell commandlet for that graphical user interface that's there. Right. So I'm going to run a set VM network adapter for the name of the VM that I want to run that against. And the maximum bandwidth that I'm going to allow.
It's 5,000 by look of things.
Yeah, which is 5 megabytes. All right, so we've got a fairly large file that's going to need to copy a lot of megabytes. So we're going to limit it to 5,000. And then we're going to go back to our machine and show you how that copy is going on. And we're going to get some more details. And what do you notice about that?
The speed, yeah.
It's dropped right down, hasn't it? So what we actually see here is that it's down to 1.89 megabytes because we've put a cap on how much that can actually copy. So let's go back and remove that quality of service bandwidth on that particular machine. So let's go back to our machine, and we're going to go and set a VM network adapter, same command, but we're going to put a 0 at the end, and that's going to remove the cap on how much bandwidth that machine can actually copy. And then we're going to go back over to that machine. Sorry, meant to run that, and then we're going to go back over, and what do you notice on that screen now?
Yeah, the speed is, a lot
it's
higher.
jumped right up, and if we go and refresh this, you notice it maintains its speed because it's got the maximum bandwidth. So you can see fairly quickly through the GUI and through PowerShell, we can enable quality of service and really control what's going on with our virtual machines.
Okay.
Pretty cool, huh?
Great.
Okay, well, one of the key features of virtualization is enabling multi-tenancy. And I guess I'm hoping you can help me understand something that I've always struggled with a little bit, is the concept of a VLAN and also its limitations and what Windows Server 2012 has done with, I guess, network virtualization to ensure the necessary security and isolation for different applications or users.
Yeah, well, I mean, if you look at isolation and multi-tenancy, Microsoft, we've been running large-scale data centers for about probably since 1994, before it was even called cloud computing. You're
referring to Hotmail.
Hotmail. I went to the Hotmail installation in 1999, so we've been running these large data centers for a number of years, and we've learned a lot about what it takes to run a public cloud. One of those is isolation and multi-tenancy. You need to be able to isolate customer workloads from other customer workloads. And in a public cloud, you've got different customers that are that could be on the same same Hyper-V host or different Hyper-V host, and we have to have some isolation. So we've taken some of the technologies that we use in Windows Azure, particularly network virtualization, to be able to bring that down into the operating system. So as customers are actually starting to deploy private clouds or a hybrid type scenario, they need to be able to virtualize at the network layer. Okay, so VLANs tend to be kind of hard to set up. They're limited in the number of VLANs you can actually have. There's a lot of renaming that needs to go on, because when customers build applications, they have certain IP addresses that they want to actually use. And what network virtualization does is it gets around those issues with those. Because what we do with network virtualization is we introduce what we call IP portability. And what that means is that we for the workload, we have the internal IP address that the application uses, and then we use the provider address. And the provider address is the address that's on the hosting provider or the administrator's network, that allows us to keep the internal application's IP details and then allow us to keep that isolated from other workloads. And then we can measure this with resource metering. But the first thing that enables a lot of this is what we call PVLAN. Okay. So you thought you were confused before. Now you're going to be even confused more. We have this technology called private VLAN. So the private VLAN is one of the big things around multi-tenant security and isolation. So on this slide here, what you're actually seeing is this is about isolating virtual machines from each other within the data center, whether they're sitting on the same Hyper-V host or whether they're sitting on different Hyper-V hosts. So we need to be able to have what you can see here on the diagram is we need to have an isolated network. And that isolated network is an isolated network that the VMs can actually communicate on. We can have different modes that we can set up so that those particular VMs don't conflict with other VMs and don't have the ability to communicate with those other VMs. Okay, so it allows us to get around the limitations that we have with with VLANs themselves. VLANs are essentially a technology that essentially allows us to subdivide networks. And what private VLAN allows us to do is do that at a virtual machine level. So here what you're actually seeing is a couple of guest operating systems, and we have a couple of different scenarios here. And you see the red X's means that we have, these could be two different customers. Right? And we want to make sure that they're isolated and their data is actually protected. So we have that ability in the operating system to isolate these sets of VMs from communicating by being able to put them on a particular type of private VLAN. And the 4 types we have are isolated, community, promiscuous, and trunk mode. So we can actually set the different types of networks that they're on, and that will determine whether they can actually communicate with each other. And then network virtualization allows us to keep their customer, say this was customer A and this was customer B in the yellow, and they had the same IP settings. What do you do? Right? We can keep that those settings together, and we can do that through the provider address. Okay, so there's some pretty cool things that we're actually doing in the operating system to enable that. And that's something that, again, we built in, that we learned that was something that was very much needed in a private cloud environment on-premise at customer sites. So we added that in, and then if you look at this again, here's the guest operating system that's running in promiscuous mode. That is, that particular VM can communicate with all the VMs running in that mode that's open.
Which one's that? Sorry, the
That's the grey one. Yeah, you see that it doesn't. You can see the traffic as it goes through, and you see that the blue ones are able to actually communicate with each other, but they're not able to actually go and communicate with the yellow one. Okay, so we're trying to make sure that we can isolate them, but still keep their existing IP settings, and that's the thing that's been added in. And then we want to scale beyond VLANs by being able to have a technology that's built in called network virtualization. So network virtualization is solving 2 problems. It's solving the restraints that we currently have with VLANs, which is 1,000 VLANs that can be created, and helps eliminate hierarchical IP address assignment for virtual machines. So customers are not going to have to actually go and reset and rename and redo all their IP settings for their sets of virtual machines that are running their applications. What we tend to do is we use a technology called general routing encapsulation. We do IP address rewrite, and we do that by providing a provider address. So it ends up having, as a virtual machine ends up with 2 IP addresses. One's a provider address that the hosting provider or the network actually has, and then there's the IP address that it had when it was put into a virtualized environment. And so if you build this out a little bit, you can see that This allows us to create different networks for those applications. Okay, so here in this particular scenario, the blue virtual machine is communicating through the blue network to the Hyper-V hosts. And the yellow one is communicating on the yellow network. Okay, and what that means is that they can keep their existing IP settings, but we can still host them and we can serve their needs.
Okay.
So it's pretty awesome what we can actually do now with this isolation, having it built in.
And I think the final thing we said we'd talk about today is resource metering, which also falls under the network virtualization banner. Resource metering, I understand, is trying to assist with giving visibility over which business units are using which applications, or if you wanted to set up chargeback or that.
Yeah, because again, when you're trying to deploy a private cloud, you need to be able to have some sort of way to be able to charge for the resources. I think a lot of times businesses don't realize that IT resources are limited. Yep. It's not a case of just going and buying a new hard drive up at Harvey Norman and plugging it into a server, right? I mean, storage costs money, networking costs money, because when we're delivering a private cloud, what we're trying to actually do is to deliver IT as a service. So it's about delivering compute, networking, and storage as the key areas that we need to deploy. And so what resource metering allows us to do is to charge for each of those pieces. And then that allows the IT department to be more self-sufficient because they're getting money for the resources that they're actually providing. So what resource metering allows you to do is to, one, get some metrics. How much CPU is a virtual machine using? How much memory is a virtual machine actually using? How much maximum memory is it actually using? How much disk is it being used? And then that allows us to go and create resource pools and to create metering to allow us to then charge back to the business for the resources they're using. Okay. And when you build this out, for example, and we just enable this through PowerShell. It's enabled for us to turn on resource metering. And what that allows us to do is to track what's going on with those virtual machines, to see what's going on with those. And here, if you build this out a little bit, what this shows you is we're just assigning a number that we've predetermined to the business, what that's actually going to be. So for example, this is saying 45, but that actually might be represented in how much we're going to charge the business for the number of gigabytes that they're actually using. So it just allows you to understand how much traffic is coming in and out of these virtual machines so that we can then implement a chargeback model.
Great. Well, let's open up PowerShell and have a look at how it works in practice.
Yeah, let's go ahead and have a look at the demo, because always these things actually look better when you show a demo. So let's have a look and see what it looks like. Okay, so we've talked a fair bit about how we can actually start to do chargeback for the resources that people are using on the virtual machine. So what I'm going to show you in this demo is a little bit about what resource metering actually looks like. And this is a feature in Hyper-V that allows you to say, I want to charge so much per megabyte or so much per gigabyte for CPU, for network, and all that sort of stuff. And so that the IT administrator can actually start to deliver IT as a service and actually charge for the services that people are actually using.
Or at least even provide visibility of what people are using.
Exactly. It could be either visibility, or it could actually be just so they know how much they're actually using, and then they can use that as evidence for them to be able to actually charge. So let's go and have a look at what that actually looks like. So we're going to open up PowerShell, and we're going to open up a script to set this all up. And I've got a PowerShell script that's here, and this has got some commands that allows us to actually set this up. And to set the scene here, what we're doing is obviously we need to enable resource metering, which by default is not turned on. Then we need to go and measure that virtual machine, and then we need to put some calculations into some variables. So we need to go in and put some calculations in, and these are all just saying how much we're charging per gigabyte, how much we're charging per gigahertz. I think your readers are probably very familiar with gigahertz. Cost per gigabyte, network cost per gigabyte, how much traffic they're actually, before we saw quality of service. Now we go into the scenario where we can actually start to measure how much this and be able to charge that back. So let's go and enable this first. So we have to run the first PowerShell script, which will enable resource metering. Then we have to go and measure a VM. So which VM do we want to measure that on? And we're going to go back to our good friend, our domain controller here, to measure how much that's actually going on at the moment. And you notice here, you notice on the screen that we get some statistics back on how much data this is actually using. it gives us average RAM, average CPU. So we get some intelligence about how much that actually machine is using. And we can start to then work on some calculations with the business and say, look, over a period of time, your virtual machine has used this amount of data. Mm-hmm. So let's go and put our PowerShell script, and this is essentially just putting this into a variable. Then what we need to be able to do is we need to go and measure that. Okay, and we've got some stuff in there that tells you how much we're going to charge, and then we're going to calculate the VM cost, then we're going to reset it, and then we're going to calculate it again. Okay. All right, and this gives us some averages. And what you can see here is that down at the bottom here, this spits out some numbers about how much that VM actually cost over that period of time. And this is giving us a number that we can then go back to the business to say, this is how much you're going to use on a per hour basis or a per week basis or whatever you actually, however you want to actually slice it up. And that just gives you, shows you how powerful it is to be able to turn on resource metering fairly quickly and do it in an automated fashion.
And these scripts, where would our readers find examples of these scripts if they wanted to, have a bit of a head start on something?
Well,
like
they can get them. First of all, there's a lot of resources on the iTnews website. Plus, there's also a bunch of scripts that are on the TechNet Scripting Center. And we'll put a link up to that up on the iTnews website so we can get that information. And there's all kinds of scripts that the community's sharing, okay, and that other people are uploading. Scripts that I've used, I get a lot of these scripts from the TechNet Scripting Center. So what did you think of that, Brett?
Excellent. I think a lot of IT administrators will be very happy about it. Maybe some business units that are going to get a build might take some getting used to, but
we'll keep them honest, right?
Okay. Well, unfortunately, I think it's probably the last demo we're going to have time to show because we're running pretty short of time. I want to thank you for coming in.
No problems. I'm glad to come out and talk about it. It's great.
Excellent. And I want to thank all of our readers for logging in and checking out these new features. I'd also very much be curious to know what you think of this new format, the Academy format for a webinar. I hope that you've enjoyed the interactivity of the demos. Please do write to us at editors@itnews.com.au and let us know what you think. But before we close off, I guess I wanted to stress as well that there are a whole bunch more demos you can see at the Academy website, itnews.com.au/academy. But also Jeff has some other resources you might be interested in if you wanted to learn more about these features and others in the infrastructure world.
Yes, oftentimes when people ask, when we get to the end of this, how do I get started? Yeah. So we have really just 3.5 things really that I want to tell you is that look, they can go to our TechNet Evaluation Center and they can download a 180-day trial of Windows Server 2012 if they want to have a look at it. The other thing is we do these in-person training things we call IT camps, okay, and essentially these are in-person training events. It's no cost to you. You come in and get a deep dive on a particular technology. Later this month, we're actually doing some on System Center 2012. Or they can, if they prefer to sit at their desk and do stuff online, they can go to the Microsoft Virtual Academy. And there's a whole bunch of different courses on not only Windows Server, but a whole bunch of other technologies. And then for people that are local to Australia, in September later this year, we have our big TechEd Australia event that's going to be from the 3rd to the 6th of September.
Up on the Gold Coast?
Up on the Gold Coast, yeah, at the Gold Coast Convention Center. And we'll be covering a lot of technologies across the Microsoft stack. We'll be also covering a lot of the new stuff. I don't know at this stage what we're going to be covering, but it's going to be a lot of good fun, and it goes for 3 days. It should be a good event. Excellent. And registration is open now. If people wanted to actually register for TechEd, you can register on Early Bird, which is open right now.
Great. Well, thanks again, Jeff. I really appreciate you coming in.
No problem.
And speaking of new features, we've just uploaded to the Academy website the white paper for the Windows Server 2012 R2. Before you get the chance to play with it, you might want to read about the new features that are coming out. Thanks again for joining us, and we'll see you next time on iTnews Academy.